All right, in this first example, here's the situation. We have Sally who has invested $25,000. 10 years after she invests it, her money has doubled. And we want to know when will it triple. So and we're going to assume continuous growth. So when we assume continuous growth, that means we are going to use PERT. That's the formula of choice. So this is a multi-step problem. So the first thing we want to do is we want to make kind of a little T-chart of the information that we have. So we know that we've got money or the investment in one category, and then we know we've got time in the other category, and we know that this is years. Okay, so we first start by filling out what we know. We know that she invested $25,000 at some year, and we're just going to call it year 0, because that's when she, if you will, that's when you start the clock ticking. At year 0, she invested her $25,000. We know that 10 years later, her money has doubled. So if I had $25,000 and it's doubled, I now have $50,000. And so with this information, we're going to solve for R, the rate. So remember, we're going to use PERT. Right here, we're going to use PERT. So A is the amount that you have after time. So that's $50,000. And our initial amount, that's P. So that's $25,000. E to the R, and our time is 10, because it was 10 years for it to double. And now we're going to solve for R. So I'm just going to put this over here. Solve for R. So we're going to do that by dividing both sides by 25,000. So then you end up with 2 equals E to the R times 10. Now I'm going to natural log both sides. Take the natural log of the left, take the natural log of the right, and when I do that, I have the natural log here. It releases the power, so to speak, so the whole exponent can come down. Okay, the ln of E is 1. And now I'm solving for R, so I'm going to divide both sides by 10. And when I divide by 10, that gives me R equals 0.0693. We always want to use 4 digits on paper. And in the next example, I'm going to show you how to do this with your calculator and second answer. Okay, but we'll save that for the next example. So there's my R. All right, so step 1 is done. Now I need step 2. So step 2 now I can answer the question, when will it triple? So let's go back to our chart here a minute. When is a time, so I'm solving for time. And if I want to know tripling, well, $25,000 tripled would be $75,000. So let's set up our equation. $75,000 equals $25,000 times E, and now I know that R, don't I? 0.0693 T. I'm solving for T. I'm going to divide both sides by 25,000. And when I do that, I get 3 equals E to the 0.0693 T. Now we want to take the natural log of each side. And I am running out of room, so follow my arrow. We're going to move and continue our work over here. So now I've got the natural log of 3 equals 0.0693 T times the natural log of E. The natural log of E is 1. We want to divide by 0.0693. 0.0693, both sides, 0.0693. So t is going to be equal to the natural log of 3 divided by 0.0693. When you type this in your calculator, you type in natural log of 3, of course, don't forget your parentheses. But then when you type this in, now here you can use that second answer. And again, I will illustrate that on the next example. So when you do this, you should get 15.85. And our units on this is years. So that's a multi-step process for solving these word problems using logarithms.